Cool. All right. Welcome back, everybody. We're going to continue this talk on data transmission over radio. It's turning out to be a very Winlink heavy day because I'm going to talk about protocols, how they relate to digital communications. That's going to be sort of a more theoretical part of the discussion. But then we'll also apply, how protocols work. We'll apply that to, how Winlink works. And then we'll also talk about one of these alternate Winlink clients called PAT, which I think is a lot of fun. My name is Chris, K0SWE. I'm involved in Aries. I'm involved in RMHAM, obviously. Professionally, I'm a software engineer, and I love giving back to the hobby through that means primarily, is developing new software and trying to fix up old software as best I can. There's only so many hours in the day, though. Right, so to motivate this whole discussion, I'll say that Winlink is not just one program. Gary already mentioned that there's several programs put out by Amateur Radio Safety Foundation, which is the parent organization for Winlink. It's not just one or a few programs, it's an entire ecosystem. There's lots of programs that communicate together. And I'm gonna cover how that actually works, how they can manage to talk to each other. So we're gonna start out with sort of a theoretical discussion of protocols. And before I got into programming, that was kind of a weird, almost scary word. It's a big technical term, and what the heck is a protocol? What does that mean to me? So we'll spend a little bit of time defining what that is. So the one place that everybody thinks of protocol in a human context is if you're meeting the Queen of England, there's a protocol for how you're supposed to behave, the way you're supposed to address her. It's not, hey, Liz, it's Your Majesty, right? There's a certain order in which you do things. There's a certain order in which everybody sits down, everybody stands up at dinner, place where you stand when you're taking a picture. And if you break the protocol, it can cause a lot of confusion. It can get people upset. It can cause an international media outrage. So, on the air as hams, there's also voice protocols. When you're listening to a contest station, you hear somebody running a frequency, there's a very predictable flow about how people call and respond. The running station says QRZ. Several people call back. The running station picks one of them. They exchange their signal report and their serial numbers, and the running station goes back to QRZ. If somebody breaks in with a rag chew, people are going to be confused and upset because somebody's not following the protocol. They're not doing things in the same order as everybody else. There is a protocol for contesting. There is also a protocol for rag chewing. It's a loose protocol, but there's still, people are talking the same language, and so those two things don't mix. So when we're talking about computer protocols, it's the same thing. These two computers have a prearranged order in which they're going to say certain things to each other, and if they don't say things in the right order, they're going to get confused. So I think about computer protocols as a language. If these two computers are talking the same language, they're going to be able to understand each other. If they're not speaking the same language, then they're just going to confuse each other, and they're going to be noise to each other. That's the bottom line when we're talking about protocols. It's a language, it's the order in which we do things. Another point to make here is that protocols are not necessarily just simple back and forth. Protocols can also leave room for payloads. So for instance, you've got an IP address, and that's at the IP protocol level, it's just an envelope. You put the address on the outside, but there's room inside the envelope for you to stick other things. Stick whatever you want inside the envelope, and it will get delivered because it's got the address on the outside. So in this way, we've got protocols that allow you to store other information inside. It allows you to encapsulate information on the inside. And that becomes important when we start talking about Winlink. Why do we have these layered protocols? Why don't we just have one protocol all the way up and down? Well, they solve different problems, and you can reuse low-level protocols for higher level uses. Everything on the internet runs over IP. Most of it runs over TCP. We didn't have to redesign a protocol for web browsers and an entire protocol for email and an entire protocol for chat. We were able to reuse a lot of the work that we already did because we reused the IP protocol. So you've got, there's actually a stack of 7 layers. That's the wrong 7 layers that I was going to talk about. There's a model called the Open Systems Interconnection, OSI model, and it defines 7 layers that computers can talk about. And you've got different concerns, different responsibilities at each one of these layers. And so we can put thousands of applications up here that only need to use 2 or 3 of the protocols that are down here. We get to reuse all of the work and the energy and the time that went into designing these lower level protocols. And we get to do better, faster engineering because of that. And if we're talking about a typical computer application like a web browser, most of the these top 3 layers, these are usually implemented by the web browser itself. Maybe these 2 layers are done by the operating system, and then these lower levels are done by either firmware or hardware. Now, that's how a usual computer program works. But that's all very theoretical. Let's bring it back to ham radio and how that applies to us. So I mentioned that there's all of these programs that make up the Winlink ecosystem. The reason they can talk to each other is because they all speak a common protocol, a common language called B2 forwarding, B2F. And Gary mentioned there's the old Winlink classic system. I think that's B1 forwarding, B1F, but to my knowledge, I don't think anyone is using that anymore. Maybe. But most people are on B2F, which is the common language that all of these speak. And in fact, if here's Winlink Express, if you read through some of the log messages that are in here, you can actually see B2F language as it's happening. There's the PQ message, which is the server asking, what's your password? PR, my password is, and that's not actually the password, but it's a hash of the password. It's what the server is expecting. FF, do you have any messages for me? Either the server responds, FQ, no, I don't have any messages. Or the server might respond, PM, yes, I do have messages for you, and here's the first one. So this is the B2F protocol, the B2F language. You can see it right here in the logs here. The key part about this is that B2F, it doesn't talk about frequencies. It doesn't talk about the station you're trying to call. All that stuff is handled by lower level protocols. So we're starting to see that stack of protocols. If you're talking on Telnet, you're not worried about frequencies. You're not talking about the call sign of the station you're trying to call because you're not on RF. So none of that has to be handled at the B2F level. All that Telnet can just do its thing on the internet over TCP/IP, and all these other modes, AX25 packet or RDOP or VARA or PACTOR, they can do their work with frequencies and call signs and digipeaters if those are required. All that stuff is handled at this level. Why do we have so many of these modes? Why do we have so many of these transports? Well, Gary got into this a little bit, but they've all got pros and cons. We've got Telnet if we have internet access, and it's often the fastest way to exchange messages. It's just not very exciting for us as hams because it's not RF. But you know, if it's available, it's a really excellent way to communicate. AX25 has been around for 40 years plus. It's very robust. It's very popular. There's lots of people that are using it. There's lots of infrastructure in the way of digipeaters. So it has stuck around for a long time because everybody knows it. The contrast to AX25 is VARA FM. Gary mentioned that VARA is kind of the new kid on the block. VARA FM happens to be a lot faster than AX25, and I'll show a graph of that in a minute here. But not everybody has transitioned over to it. Also, as far as I know, there's no digipeater equivalent in VARA FM. Digipeaters only speak AX25. They don't speak VARA FM. So you can't take advantage of some of the infrastructure that the community's built up. On the HF side, we've got RDOP. Its main advantage is that it's free and open source. That's pretty much the only thing it has going for it. It's pretty slow, it's not very reliable, but it's cheap. VARA, as we spoke about, it's very fast, it's very reliable. It costs a little bit of money to license the software. That's worth doing. The other option on HF is PACTOR, which is very reliable, very fast, and relatively expensive compared to all the other options we're talking about. In fact, here's a speed comparison of these different HF protocols. This top blue line here is PACTOR 4, which I just learned from John is not strictly legal in the US most of the time unless you're working a hurricane. So that's the top blue line here. It's the fastest. The x-axis here I'll mention is the signal to noise ratio. So this is the best signal all the way down to the worst signal. And you'll see over a wide range of signal conditions, PACTOR 4 is the best. VARA HF is actually the second place here. And then this dark blue line is PACTOR 3. And there's a little section where they start to get close to a tie when it's bad conditions here. But that's pretty impressive to me. The fact that, a relatively inexpensive software mode, VARA HF, competes with, very expensive hardware, PACTOR. That's pretty impressive to me. If we go over to the VHF UHF side, it's hard to see on the monitors here, but this top yellow line is VARA FM, and they had to put this graph in log scale, they said, because VARA FM just blows AX25 out of the water when it comes to speed. There's just no competition. But again, there's a downside that you're missing out on some of the infrastructure that we've built up for AX25. AX25 is the orange line here. This green line is kind of a niche protocol called FX25. It's an evolution of AX25 that includes forward error correction. So they're sending extra bits to try and make it more reliable. Unfortunately, that means they take longer to send the same amount of information. And unless it's really, really crappy conditions, they're just not getting any advantage over plain AX25. The only exception is, here's the 0 line where the signal to noise ratio is 0. They can go a little bit into the noise with FX25 because it's got the forward error correction. But it's such a small advantage that based on this graph, I wouldn't recommend running FX25 except as, fun research into forward error correction. I wouldn't consider it a useful protocol based on what we're seeing here. All right, so this is kind of an eye chart, but this shows different ways of building AX25 packet Winlink stations. The point being here that, again, we've got different protocols that fulfill different requirements, do different capabilities, and those can be implemented lots of different ways. Over on the far left here, you've got Winlink Express as a client program. Maybe you connect that to the Direwolf, which is a software package for AX25. You connect that into a sound card for your radio interface, and that interfaces to your radio. You can achieve the same thing by using, you can replace Direwolf and a sound card with a Cantronics TNC, and that Cantronics TNC takes the role of both doing AX25 plus transferring it to audio frequency analog audio. If you've got a Kenwood TMD 710, well, that is fulfilling the roles all the way from, you've got text flowing over this connection. The Kenwood is doing the entire rest of this stack. And less boxes means less configuration, less issues in the field. I suspect WOAD, the Android client, could probably talk over Bluetooth to the Mobilinked TNC. That's another sort of modern kind of niche software setup or hardware setup. This could work, and again, the Mobilinked TNC is going to do everything down to audio frequency data, and you can pipe that into a radio. So less boxes means less configuration, but it also means less flexibility. Because these are all AX25 stations. Let's say, just for fun, that you wanted to change from AX25 to VARA FM. Which one of these stations still works? It happens that only the station on the far left is flexible enough to make that change, because you can only change out AX25 right here for VARA FM. You've still got the sound card. Cantronics does not talk AX25. You can no longer use it if you're trying to go to VARA FM. The Kenwood TNC only talks AX25. If you change out for VARA FM, you've got to treat this as a dumb radio and use a sound card interface. So pluses and minuses of trying to get more or less boxes in here. But in all of these cases, you've got some entity that is performing the AX25 piece and the digital to analog conversion and the RF modulation. You've got some thing that's performing those roles. It just might come in a different format. All right, so enough theory. That was probably a lot to take in. Let's get to the good stuff. Let's talk about PAT, which is this alternate Winlink client. We've got many clients in the ecosystem. You know, everyone should learn Winlink Express first. I will say that. That is the gold standard. That is the majority of what people use. It's the most full-featured, but there's lots of other options here, and there are reasons that you might want to pursue these other options. I'm going to talk about PAT because it's one that I do some development work on. So PAT was started in 2015 by a guy named Martin Peterson, call sign LA5NTA. He's out of Norway. He started this in 2015. This is open source and free. We build it for all major desktop operating systems, so it's Windows and Mac and Linux. One of the niches that we've found a lot of popularity is in Raspberry Pis. You know, they're tiny little computers that you can throw in a bag or stick up on a radio, stick up on a mountaintop, and they just tend to work. And as Gary mentioned, it's quite difficult to get Winlink Express to run on these. It is possible, but it's not for a first-time Linux user. It's kind of a advanced capstone project kind of thing. And I'll also mention that PAT was named in homage to Postman Pat, which I'd never heard of this, but apparently it's a British claymation kids show about a postman in Britain. And so that, you know, Martin was looking for a more playful name than RMS Express or Outpost, or, you know, this was started as his pleasure project, and it has grown into, you know, have a bit of a following. So to use PAT, there's two ways you can use it. If you're an ultra nerd like me or Willem or many people in this room, you might prefer the command line interface. You know, you can type everything out over a terminal session, and, you know, it feels very hackery, and you can do some scripting against this. You can generate emails from some program and pipe it into PAT and drop it in the outbox to have it sent for, you know, some purpose later. So that's all well and good, but what most people seem to like is the web browser interface we got here. Installation's pretty straightforward. You come to the website. We've got installers, like I said, for many platforms. It's pretty straightforward to get running. Let's take a quick tour of the user interface here. It's hard to read off of the screen here, but up in the top left, we've got connection status, so you can see pretty clearly, you know, whether the radio is connected or not. You can, similar to Winlink Express, you can set this up on a timer so it will check every 30 minutes. You know, obviously you need to be doing your due diligence as the operator and being responsible for that. The folders run across the top here. We've got an actions menu that I'll dive into. You've got the message list, and down here at the bottom is sort of a raw log of what's going on. So this is where you'll see, all right, we connected. All right, here's the B2F trans messages that you'd see elsewhere. So under the actions menu is where you find the connect command, the compose, and you can also do position reports similar to Winlink Express. This is the compose box. It, you know, like Gary said, this is very familiar to anyone who's used any email program ever. You've got you've got CC, you've got the message body. You can do picture attachments, although I found out from the mcomtraining.org exercise a couple weeks ago that we don't have a resize function. It's like pinned at 25 kilobytes instead of being configurable up or down. So maybe we'll add that soon. As of July last year, we officially launched Winlink form templates support. And so if you want to fill out in ICS 213, you can do that now. That feature was missing until about 9 months ago. And we're very proud to have that in now. This is the connection window. You've got aliases, which is sort of the same thing as Winlink favorites. So you can set up, these are the 5 RMSs that I usually contact, so I want to do that quickly. You can pick your transport, which is, RDOP or AX25 or Telnet. We just released VARA support. That's in beta test right now. So that should be coming to the official release pretty soon. Again, we've got some features that lag behind Winlink Express because, it's basically 2 of us that are on it a majority of the time, plus we get, contributions from the community. But it's hard for us to keep up with every feature that Winlink Express releases. We do the best we can. If you've got, Pat has the ability to do rig control. And so if you have that set up, Pat will set the frequency on your radio. If you don't have that set up, it will show it as struck out. It's got a line through the middle, and you just have to know to set your radio to that frequency. And we do have an RMS list, same as Winlink Express, so you can find out which RMS stations are close to you. We don't have the path prediction that Winlink Express has, and I'd like to figure out how to do that. Hopefully that's in the near future. So Colorado Aries is encouraged to standardize on Winlink Express. But there is one feature of PAT that I think could be super useful in an EOC situation. And that's the fact that PAT can support multiple users using web browsers. I've often heard it's a problem in an EOC where you've got people changing shifts and they need to take their laptop with them, or you've got, a computer that's dedicated to the EOC, but you can only have one person running that. You can't have multiple people looking at the same information. With the PAT web browser interface, you can have people looking at the same inbox. When a new message comes in, everyone can see it populate. You can all be looking at the same information. You can have multiple people running that Winlink station, and you can run it on inexpensive hardware, Raspberry Pi if you want. So I think this could be, in the future, as PAT becomes more featureful and more reliable, I think this could be a pretty powerful shift in the way that we do things, at least for EOCs and stuff. This could work well for a club too, if you got a club station that is always sitting there and multiple people need to use it. Well, they don't have to get on the physical computer. They just connect to the Wi-Fi, get on the web browser into this PAT machine, and they just use it from there. You can also have your served agencies. You can have them use their smartphone to compose their own email message if you want. Have them drop it in the outbox, and the ham operator is the one who initiates the send. That's easy too. So I think this could be a powerful way to think about things in the future. That's all I've got. It was short and sweet. Questions? Yep.
So the list of RMS servers, that shows you who all is close by you and what protocols they're using?
Yes.
Okay.
Yeah.
And that's how you select who to transmit to?
Right. Let me see if I can get this running real quick. And I will try and make this as brief as I can. Okay, let's go to mirror so I can see what I'm doing. All right, so let me start up PAT here. So this is what it actually looks like. Let me zoom in on this. So let's bring up the Connect dialog and we'll look at the RMS list. So similar to Winlink Express, you can choose which mode you're looking for, which band you're looking for. And I had already told Pat that, you know, I'm at DM79, so it has a rough distance on all these stations. It sees John's station, it sees Colorado Springs, and it sees, this guy's in Texas. I use his here and there. So, yeah, and it's got all the dial frequencies. If you've got rig control set up, then it will dial those frequencies for you. So, yeah, that's pretty handy.
And the Vera protocol is built into that?
We are working on it. It's in beta right now.
Okay.
We consider it unstable, but it's almost ready to go.
So you're using the VARA EXE and got a wrapper around it?
Yes.
Okay.
Yeah, it was a challenge to get VARA onto a Raspberry Pi because Raspberry Pis run Linux software and VARA is Windows only. So we have to do some trickery. But it does work. Yeah.
Do you have a recommendation on hardware as far as connecting this into radio? Is it always Pi is the best way, the Raspberry Pi is the thing to put it on?
That is Raspberry Pi is one of the most popular platforms that we see. There's a guy, Jason KM4ACK, that does a lot of YouTube videos, instructional YouTube videos, and he absolutely loves this particular setup. He loves Raspberry Pi for everything, and so he's gotten onto the PAT bandwagon. Yeah, he does build a Pi, exactly. Exactly. Yeah, this is PAT is included as part of Build a Pi, and so that's an easy way to get up and running. All right. If I got no other questions, Willem?
In your penultimate slide, you showed that, you know, for an EOC or a similar, you know, even if it's a shelter situation, that we can get people to connect to the PAT station and then just compose a message, and then the ham operator sends it. When they do that formulation, do they have to set all of the things like mode and frequency or stuff like that, or can they sort of more generically just format the message, and then the ham operator can go in and say, okay, I will do all of the magic to make it go?
Right. So if you were having a served agency or, you know, somebody at a shelter trying to compose their own message, you'd probably direct them to the compose page, and maybe we could make that a little bit, you know, the first thing that pops up in your face. But the compose dialog here is just to, it's going to be from the station, so they can't change that. But they can send this, set the subject, set the text body, and they just post it to the outbox. They don't have to mess with any of the radio stuff. And so that's pretty straightforward. I think most people would figure that out. So.
It seems to me this is sort of an ideal situation where you've got lots of people that need to get traffic moved, and you don't want the ham operator to be sort of an interpreter. So all they get to do is to actually provide the transport layer, and the actual served agencies are sort of at the application layer and talking directly to each other. So it seems to me this is something that would be extremely valuable if we can put this in an EOC or a shelter or places like that.
Yeah, there's certainly good applications for that.
Along those lines, like for add attachment, are there some settings that, you know, so somebody doesn't want to send a 20 meg attachment, or some limitations? I would see, you know, if this was going to be, you know, more prime time, that there's going to be some limitations if we're using a RF link.
Right. So at least for add attachment, right now the only special case we have for compressing things is images we're going to resize down to, like, I think it's 600 by 800 is the only size that we do, but it's going to smash that down to being just viewable. We can make that more configurable, but yeah, if someone sticks a zip file on here with 20 megs, it's the worst thing that would happen is it'd be rejected by the RMS and wouldn't be sent. All right. Thank you, everybody. I believe we're